What up, physics kids? It's time to learn how to do a Unit 9 Worksheet 2 problem. I'm actually going to show you how to do number 1 on this worksheet, but before we do that, I want to circle back to the notes and talk about the three possible equations you could use in collisions problems, or what are called conservation of momentum problems. And when you looked at the notes that you read through, very detailed like, because that's what you do, because it's exciting, you should have known at the bottom of the page there were a few equations for two object collisions. Now, all of these equations are based off of one thing. It's based off of that in any collision, the total momentum of all the objects before a collision is equal to the total momentum of all the objects after the collision. Now, you should have seen that each individual object can have different collision from the initial to the final. But when you add or subtract all of those momentums for each object in the collision, you should find that the total initial momentum is equal to the total final momentum. Now, there are three types of equations that you can consider equations for. The first equation has to do with elastic collisions where the objects bounce off of each other. And you can see on that equation, you have, once again, initial and final momentums equal to each other, and then you have the initial momentum of the two objects added up and the final momentum of the two objects added up. And then what you have is the mass times the velocity of each object initially equal added up, and then the mass times the velocity of each object individually in the final. And those are all equal to each other. And then there are two inelastic equations, one where objects stick together after colliding, and that's one where once again the momentums are equal to each other, but you have two separate momentums for the two objects initially, so you add up their mass times velocity separately, and then when they come together, what you can do is you can add up the masses of the two objects, and then they will have one velocity. So you add up those two masses, multiply it by this final velocity of both. And then the other inelastic collision is what it's called an explosion. It's where two objects are stuck together before the collision and then fly apart. And in this case, what you have is, once again, initial and final momentums equal to each other. But what you have is two masses stuck together. So you add up those masses and you multiply that by an initial velocity, because they both have the same velocity because they're together. And then that will be equal to the mass times the velocity of each object separately. So those are the three big equations that you will use, but they all go back to one thing. Total initial momentum is equal to total final momentum, and that's because of what is called the conservation of momentum. All right, so here we go. So when we're doing number one, we look at that and we say, all right, Kim holds a 2.0 kilogram air rifle loosely and fires a bullet of mass 1.0 grams. The muzzle velocity is 150 meters per second. What is the recoil speed of the rifle? All right, so what the heck? This looks like a situation where you have two objects stuck together at the beginning and then they fly apart. So that's the explosion equation. That's the bottom one. So before we get into one, how about we do this just to make life easier? So we're going to write the three equations at the top here. And I would suggest you probably all do that. So that's elastic. Then you have the one where the two objects are apart, and then they come together to form one combined mass and have one final velocity, and that's inelastic. Sorry about the music in the background, my dog just played with a kid toy. And then the final, the final is, wait, geez, stop. Okay, this is the explosion one. This one is also inelastic. So the masses are combined to have one initial velocity, and they split apart, and then you have two final velocities and the two masses separately. Okay, so now we have those three equations written up there, and you can look at them and refer to them as needed on this worksheet. So as I said in number one, it looks like it's an explosion problem. So what I'm going to show is, first off, the mass of the rifle. So I'm going to call it MR for mass of rifle. We can consider that M1 if we wanted to. And that's 2.0 kilograms. And then we have the mass of the bullet. Call that MB. That could be like mass 2. And that is going to be 0.001 kilograms, because it said it was 1 gram. And then we have a muzzle velocity of the bullet is 150 meters per second. So there's going to be a final velocity of the bullet that's 150 meters per second. And then it wants to know what the recoil speed of the rifle is. One other thing I can write down is that there's going to be an initial velocity of the bullets and the rifle, and that's going to be 0, because they're just sitting there waiting to be exploded apart. They're not moving along. And then what we're trying to find is VRF. So that is the recoil speed of the rifle. Put a question mark there. All right, so I told you we're going to use the explosion equation, which is the third equation at the top. So it's going to be this equation here. And goes like that. The one thing I want to point out, these can all go back to the elastic collision equation, which is the top equation. And the inelastic ones just kind of clean those up and combine things to make it a little bit easier to solve, but you could get there with the elastic equation for all of them. All right, so we know that the VI is 0, so we're going to say this whole left side is 0. And then M1, which is actually MR, let me change this really quick so there's no confusion. Sorry about this. It's okay to see mistakes though. MR plus MB, and that's going to be MR plus VRI, and then MB plus VBF. Excuse me, this is VRF. Okay, so we know the mass of the rifle is 2.0 kilograms, and we don't know what the velocity of the rifle is, so we're going to say VRF. We know what the mass of the bullet is, 0.001 kilograms. And we know that the velocity of the bullet is 150 meters per second. And so then when we solve for VRF, what we get is 0.075 meters per second. So basically what that all means is the momentum of the bullet goes one way, a certain amount, and then the momentum of the rifle goes the other way, a certain amount as well, and those two certain amounts are equal to each other. So the momentum of the rifle goes back, equaling to the momentum of the bullet going forward. And the reason those are equal is because those need to be subtracted by each other, so you get it equal to the 0 initial momentum before the explosion. And one other thing I forgot to do is I have to show that velocity as a negative, because the rifle's going back and the bullet's going forward, so one has to be negative, one has to be positive. I had the bullet as a positive velocity, so then the rifle needs to be a negative velocity. All right, so that's all I have for now. I hope this was helpful, and obviously, once again, if you have questions, please come on Google Meet, or please write your questions on the Unit 9 discussion board.